Here's a strange kind of outage. Your dashboards show every shard healthy. Latency looks normal. CPU looks normal. But one shard is timing out every request because one single key on it is getting crushed. In this video, we'll cover 4 things. How the main partitioning strategy split your data. Why a single hotkey can take down a shard while the cluster average looks healthy. How to move data between shards without dropping requests. And the one decision, the shard key, that determines whether you ever hit these problems in the first place. Let's start with the basics. Sharding means splitting one large table across multiple database servers, called shards. Each shard holds a slice of the data. No single machine holds all of it. That's how you scale past what one server can handle. On one server, every read and every write competes for the same CPU and the same disk. Split that data across 4 shards, and each machine only handles a quarter of the load. That's the entire point of sharding. The question is, how do you decide which row goes to which shard? Range partitioning splits your key space into contiguous ranges. User IDs 1 to 1000 go on shard 1. 1001 to 2000 go on shard 2, and so on. It's simple, and it's great for range scans, like fetching all orders from last week. Here's the trap. If your key is sorted by time, like a sign-up date or an incrementing ID, every new row lands on the same shard. That shard takes all the right traffic while the others sit idle. Range partitioning is simple, but it concentrates fresh, high-traffic data on one machine. Hash partitioning runs the key through a hash function, then assigns the shard based on the result. 2 keys that are numerically close, like user 1000 and user 1001, can land on completely different shards. This spreads writes evenly, most of the time. Hashing spreads keys evenly across shards by count. It says nothing about traffic. If one key, say a viral post or a celebrity account, gets 1,000 times more reads than a normal key, its shard gets 1,000 times more load. Hashing can't fix that. This is the hot key problem, and it's coming up next. The third approach is directory-based partitioning. Instead of a formula, a separate lookup service tracks which shard holds which key. This gives you full control. You can move a busy key to its own shard on purpose. The cost is that the lookup service is now one more thing that has to be fast and highly available. Notice that none of these 3 fully solves the hotkey problem. Range concentrates fresh data. Hash spreads by count, not by traffic. Directory just moves the decision somewhere you can adjust manually. Whichever you pick, you still need a way to detect and handle a single key that's overloading its shard. That's next. This is the failure from the start of the video. One key on one shard is getting far more traffic than any other key in your system. That shard saturates, but your monitoring, if it only looks at cluster-wide averages, won't show you where the fire is. Say you have 8 shards. 7 are fine. 1 is pinned at 100% CPU and dropping requests. Average that across 8 shards, and the number still looks reasonable. If you only alert on the average, you'll never see this shard failing until users are already complaining. The first fix is visibility. Track metrics per shard, not just as a cluster average. Alert on the worst shard, not the mean. That alone will show you a failing shard minutes or hours before a customer opens a support ticket. Hotkeys tend to come from the same few places. A post goes viral and gets read constantly. A high-profile account generates way more activity than an average user. Or a client times out, retries, and rehits the same key, which slows it down further, which causes more retries. Once you know the patterns, you can watch for them. The real fix is per key tracking. Count requests per key, not just per shard. Set a threshold and flag any key that crosses it. Now you catch the hot key while it's a warning, not after it's already an outage. Once you've found a hot key, you have options. Cache it, so repeated reads never hit the shard. Split it further if the key itself has enough data to deserve its own partition. Or rate limit it, so it degrades gracefully instead of taking its neighbors down with it. Eventually, you'll need to rebalance, meaning move data from one shard to another, usually because a shard is too full or too hot. This sounds like a simple copy operation. In production, it's one of the easiest ways to cause an outage. The naive approach is, copy the data from shard A to shard B, then switch traffic over. But your application keeps serving live requests the entire time you're copying. A write that happens mid-copy might land on the old shard and get missed. A read-write after the switch might hit the new shard before its data has fully arrived. Either way, requests start failing. The safe approach has a name, dual write with shadow read. Instead of copying once and switching, you write every change to both the old and new shard at the same time. You keep reading from the old shard but quietly read the new one too, just to compare. Only once the new shard's reads consistently match do you cut real traffic over. In practice, this is 4 steps. Turn on dual writing to both shards. Backfill the new shard with the historical data it's missing. Shadow read from the new shard and check it against the old one without serving that result to users yet. And only once you trust the match rate, cut traffic over and retire the old shard. Dual write and shadow read take real engineering effort. If a shard is small enough to rebuild from scratch in a maintenance window, just do that. Save dual write for the migrations where downtime or data loss is genuinely not acceptable. Here's the part that actually resolves everything we've talked about. Hot keys, painful resharding, uneven load, they're all downstream of one decision you make on day one. Which field you use as your shard key. A good shard key has 3 properties. High cardinality, meaning there are many distinct values, so no single value can flood one shard. An even access pattern, so no value is read or written far more than any other. And it matches your most common query, so a typical request only needs to touch one shard, not scan every shard to find its data. Compare 2 choices that look equally easy on day 1. Shard by sign-up date, and every new user, your highest traffic group, lands on the same shard. Shard by a hashed user ID instead, and new users spread evenly across the whole cluster. The 2 choices take the same effort to write. Only one of them causes a fire later. This is the real takeaway. If you pick a bad shard key, per key monitoring and careful resharding aren't nice extras. They become mandatory maintenance. Pick a good shard key, and you'll still need those tools eventually, but you'll reach for them far less often. Everything else in this video, per key monitoring, caching a hot key, dual write migrations, is treatment. It manages the consequences of a shard key that concentrates traffic somewhere it shouldn't. Choosing the right shard key up front is the only step here that's actual prevention. Let's recap. Match your partition strategy to how your data is actually accessed, not just to what's easiest to implement. Monitor per shard and per key, because a cluster-wide average will hide a shard that's actively failing. And when you do need to reshard, use dual write and shadow read, never a blind copy while traffic keeps flowing. If this saved you from a shard key mistake before you made it, that's the goal of this channel. Hit subscribe, and I'll see you in the next one.